right, perfect. Let's get started then. So yeah, I mean, the goal for today is definitely to teach you all a little bit about AI, first of all. I think it's coming pretty fast. And I think it's just gonna be a lot nicer if you understand, first of all, a bit like what's the terminology, how does it work behind the scenes, not as magical as people like to make you believe. We'll also talk a little bit about something we're working on with ELOs, so to automatically design implant models and go beyond that. And then also, like, of course, how is this going to impact? Like, we personally are a CAD design, automatic CAD design, but of course, much broader than that. So I'll try to give you my 2 cents on how I think AI will impact the lab for the, let's say, next 2 years. All right. So first of all, a quick introduction. Like, why do I have any right to speak on this topic? Not because I'm Belgian specifically, but I did study a master's in engineering. So I wrote my thesis on AI, and that's also during that year actually that we co-founded Relu back in 2018. And so now we've been at it for quite some years, being one of the main AI companies now in dentistry. And so by doing that, we now automatically design things like night guards or crowns or custom trays, for example, do bracket removal. And I think that's just a list that we're gonna keep on adding. There's so much like RPD frameworks, full dentures, that still needs to happen. Overall, the goal, of course, is not to just fully automate everything. I think we'd like to, but the reality is we need everybody to stay in control. So that's why we also built the CAD tools to allow you to change everything if you didn't like the AI proposal. But at least it's getting you 95% of the way there, hopefully, and make sure that it's not too hard to learn. All right, so secondly, we, of course, as a company, we're always providing, first of all, our AI components to existing software companies. So that's what you see a bit above. In the last 12 months, we didn't only sell to software companies AI components, we also started building our own appliances directly. And so now we're working more with like New Image or Peterson or Neolab, specialty appliances, some European labs. So that's been moving fast there. All right, but let's talk a little bit about why, first of all, should you care about AI automation? I think, first of all, it's gonna be a big global leveler. You know, like when you think about also employee costs, for example, you know, when you go to India, a dental technician is about $5,000 a year. We need to make sure that efficiency also stays high here in the US and that all the labs stay here, all these jobs stay here. And I think that AI is going to level the playing field quite a bit. That makes that you can still do made in the USA, but at a competitive price point, of course. I think also it's going to be a transition in the upcoming years from very manual labor to more and more like, tech-enabled craftsmanship where AI will play a role there. I think secondly, it's also about protecting your reputation, right? Like what I'm referring to here is just about redo specifically. Nobody likes to make mistakes in the process. Nobody wants to do redos, but we definitely believe that AI will lift up the quality overall, like just have a good base consistency in the lab and just have a very high consistency, which will just increase profits. Finally, I think it's also a talent multiplier. There's not that many dental technicians out there anymore, like globally about 2% less each year, sadly. So that, I think you all feel that, like it's not so easy always to find dental technicians, to train them, to keep them. So making sure that the AI can also make sure you can still grow efficiently without having to 10x your team. And then also, let's say, turning a junior technician a little bit faster into a master designer. All right, anyway, luckily I don't have to convince most of you. You are apparently to LMT magazine already using AI quite massively, right? So 61% of labs is already using AI for appliance design, also for administrative work. I don't know, just a show of hands, like who uses AI already for appliance design in the lab? Somebody? No one? No. Impossible.
Well, what do you mean by AI?
Like crown design. You do crown design.
Exocad.
Exocad, reshape, automate. those things. Yeah, okay. So I think that's what they mean here. So overall, like a lot of people already use that. Okay. Now, as I was saying before, it's quite important that I think also understand a bit like AI, like the terminology that we typically use as a software company. I feel like being in a dental lab space for a little bit now, you guys taught me so much about this field. I feel like we have to return a favor, teach you guys a bit about the software world also. So let's talk a bit about artificial intelligence. First of all, what you probably all know, AI is a very big concept, right? Like it's not all ChatGPT. It's much wider than that. It's anything that a computer can perform, where a computer performs tasks that normally need human thinking, like driving a car, like filling out, like reading an order form, things like that. That can be AI in general. Now, the simplest example doesn't have to be some fancy ChatGPT tool. Like you could do in dentistry something like, oh, I have a tooth. And if there are brown pixels on this tooth, I'm going to say there's a cavity there. Like that might not work great, but it's AI. Now, because that doesn't work great, like if you would have to write if statements in code for every possible different type of cavity out there, or every different type of margin line out there, like, I mean, that's just no beginning, right? So that's why machine learning, of course, takes off. Like it allows you to, without writing a ton of code and every exception out there, make the machine learn by itself. And so machine learning is just a way for computers to learn from data, and you have to see that as a subsection from artificial intelligence. What do we do here? We just feed a lot of data, and we're just going to say yes, 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 no, for example. Like that could be one classifier. Is there a cavity or not? Order of magnitude, you're not going to make this work with 6 images. You have to think about 100 images for like a first proof of concept. Let's say 500 to get it 80, 90% of the way. And if you really want to get it to human performance, you're looking at thousands to 10,000 images ballpark. Not millions, but 10,000. Say for margin lines, right? If you want to detect margin lines, talking about 1,000 scans will do, where somebody marked a margin line and we learn from that data. All right, so that's machine learning. But then of course, one thing that happens to work super well is this thing called deep learning. So deep learning is again a subdivision of machine learning, and what's the typical framework is a neural network. I'm not going to go into the details of the mathematics of neural networks, but just fun fact, the reason it's called deep learning is because there's many layers. It means that we're doing a lot of multiplications. One machine that is very good at multiplying matrices, which is like a data form, are GPUs. Right? GPUs are very good at multiplying stuff. There's like a GPU in my computer because it has to render this image. And this image is also like data, right? Like I'm showing the slide. Every pixel on the screen are 3 numbers, RGB, right? What are the red values, green, blue? And GPUs are very good at calculating those types of things. And that's why NVIDIA is just very rich now. Because now AI is also doing a lot of these multiplications in neural networks. GPUs already knew how to do that for gaming, et cetera. So that's why they're being used so much. All right. Another level deeper is generative AI. Generative AI is, of course, the one that is ChatGPT, Gemini, whatever, asked it, what does an AI agent in a dental lab look like? That's what it gave me back. But it's pretty good, right? I mean, honestly. So generative AI, you're generating something from scratch. You are taking a prompt, an input, and you're generating an image. You're generating text. You're generating a video or sound. Now, we all know that these types of systems, they can hallucinate, right? Sometimes, I don't know, do these microscopes even make, I don't know, like sometimes they will do things that just don't fully make sense. But when we're generating a crown or we're generating a denture or a custom tray, you can't have these things completely make up random stuff. So that's why generative AI in the context of CAD design is a completely different technology that is being used or different mindset. And that's segmentation and classification, which basically means finding things and naming what they are. This is very similar to the example I gave before with these images and the cavities, yes, no. Like you would classify, is there a cavity? Here is a good example, but with a cat. So image classification, is this a cat, is this a dog, is this a banana? Object detection is telling you a bounding box where this thing is. And then segmentation means you are coloring the pixels. Okay? So in CAD design, we're doing a lot of segmentation specifically when it comes to AI. For example, you might segment, again, the margin line. You might segment the outline from the custom tray. You might segment where there is a tooth. Okay? So what are AI agents? Somebody know what an AI agent is? Somebody want to give me a guess?
It's like the Matrix.
Yes, I wanted to put an image of the guy from the Matrix on here. No, AI agents are, I mean, everybody has used ChatGPT or something, right? So ChatGPT is just giving you, it's like a consultant. It's giving you tips like, oh man, that's an awesome idea, but maybe you should do it like this. But that's a consultant. An agent is where we're taking it one step further, where it's actually becoming a coworker. So the main difference is that agents can also act. So they can send an email, they can download orders for you, they can start a 3D printer or mill. And of course you give it like guardrails so it doesn't start doing crazy things. But the way to look at it for me is if you want to talk about an AI agent, you let the AI agent click buttons for you. And you don't let ChatGPT click buttons for you, it's just telling you stuff to do and generating an image. So I think AI agents are a big topic right now in AI world, like Anthropic, for example, just came out with co-work. And that's something we'll see coming in the market a lot, where you have all these portals, for example, like the Medit, the iTro, the tree-shaped portals, like letting them all aggregate everything. Could be one use case. All right. That's a little bit jargon from the AI world. I think that gets you like, honestly, 90% of the way. Next thing I want to talk about is the automatic implant models we're doing with ELOs. So making implant models just takes time. Like, ideally, we try to automate that process. And I want to explain you a little bit on that flow as an AI company. How do we do that? Like, what's going on in this entire flow when we're making implant models? What AIs are being run? So we start from a series of inputs. For example, we have the scan with the scan bodies. We have one without. We have a series of files that we have to align or make Booleans with. I feel like some people think that we just put this in some AI model and that we then just like, bam, these things just come out of it directly. Just to be clear, that's not how it works. I think you should rather look at it as if we're using ExoCAD behind the scenes and we're just doing all the steps that you would normally do, but we're just doing them with AI. Like if you are going to indicate somewhere where the scan bodies are, then we'll do that step. If you're then going to align it, then we'll do that step. Like it's also a very much a step-by-step approach. So it's not one AI actually, specifically here we would use 5 different AI models to make one simple implant AI model. All right, first step that we need to teach is where is the scan body? So what we would do typically is we would ask you, okay, give us these 1,000 scans with scan bodies, indicate where they are, and then we'll train an AI to learn, oh, this is a scan body. But these would be too many pixels or too much data at once. So that's why we first do a general detector, then we crop it, and then we do very fine segmentation on where exactly is this is the scan body, and then we can crop a file out of it so we get a new 3D model. And so that's another AI. This is like a real fine segmenter. So just from the thing from before, this is like image classification, but also detection. This is doing segmentation. Okay. Third is alignment. Now we need to train an AI model to actually align these two things. Fourth would be gingiva segmenter. because we need to make a model. When we get a model in, there is a lot of artifacts on the sides. It's just not going to look nice. So we need to clean it up completely. We need to make sure we cut it so that we can make a nice model out of it. Then we need to determine the orientation of this model. Like the computer has no idea. Like we as people know, oh yeah, the teeth are here. No, the computer has no idea. Like, so you need to train it for a model to know, oh yeah, this is more or less the orientation of this model, and then you can put a base on it, of course. Like honestly, if you wouldn't, you could just put a base in that direction or this direction if you don't have this AI in there. And then honestly, if you combine all those things together, you'll have a series of Booleans that are being done here. And finally, you will have your implant model. Now, of course, the workflow that we're working towards here with ELOS is not that you just make an implant model. It is that you can give the input files, automatically puts the abutment on top, automatically designs the abutment if that is what you want, and then automatically designs the crown or bridge that goes on top of it. You get that full proposal, and then you can start tweaking it the way you like it. Okay. Now, how can AI impact my lab in the next 24 months? Like I wanted to scope it to 24 months. AI goes so fast, like maybe in 36 months, like we were, yeah, just all taking over the world, I don't know. So I think a good mental map for you is like where AI is going to be, just wherever there is digital data and software. If there is data, if there is software, like AI can be deployed there. It can start doing stuff there. So when we look at, if I say it's going to be impacted where there is digital data, let's just run through digital data in a dental lab and talk about how is that going to then be impacted by AI. First of all, of course, you have your orders. You probably get those in through the intraoral scan portals, and you get them in through RXs that you receive the order forms in paper. I've used a bit the Evident or the Evismart model and how they map these things. So first of all, you're going to have a downloader, right? That's one of those agents that is just going to automatically go on all the portals, download everything. Same for the digitizer. We'll have OCR. Like you probably just take a picture or you scan it. It's going to read what text is on there instead of somebody typing over this text into your lab management system. There are already a few solutions out there that do this aggregation. Like there is Digilab or LabTrack. Evident also has a solution there. For the digitizer, also Evident has a solution. Furthermore, then you need to start doing quality control. Okay, so now I have this file, it came in 2 minutes ago. Let's check, was the quality good? Like how was the prep? Was this prep done well for me? Do I have all the information that I need? And I think like us, Movix, BiteFinder, they have solutions for that right now. But I think also importantly is the communication part. Like if this thing wasn't good, then you can also now start having agents that are then going to say, look, we detected that this wasn't good, instead of then somebody typing the same email so many times a day that the scan was not good. Have the AI automatically take screenshots, automatically put it in an email, and send it to the dentist, for example. Okay.
So how fast can that do that?
That's going to take, like normal AI model for this will take about 1 minute to process and send the email.
Time that they send you the file, it can shoot them back an email saying it's a no-go.
Yeah, 1 or 2 minutes, they would have that back. Yeah, exactly. I think that's the advantage also with the AI is that it's just going to then happen automatically. Whereas now, of course, you have people checking it, it's going to take more time. Although then what is going to take time for this to then be fully deployed in 2 minutes is that you need 100% faith in that thing. And that way AI will take, like you will not have that tomorrow. Like now, if we do this, we'll definitely still have people looking at the results. Okay. Communication, so I mentioned that part where the agent actually sends emails for you, where it updates your team, whatever. Data entry, I think that's going to be a very hard one to crack for AI companies, because when we're talking about labs on this topic, it's not so black and white. It's not so as easy as you might want it to be, right? Like you just have like Bob, which is a dentist that comes to our lab. We know that if he wants an A2, he actually wants an A3. And so, you know, those things like AI can't know that type of stuff, right? So if he would actually always say A2 means A2, then yeah, of course you can just copy paste it in there. but that logic or that knowing what to do, I think the way that will enter your lab is that it will do it, but you need a good interface to define all these exceptions. And I'm sure there are thousands. So probably what you'll get is going to be like a text box or something where you just type, like you type in ChatGPT, hey, that was wrong. Like you gave Bob an A2, but actually when he says A2, it's an A3, enter. And that's saved. You don't have to set anything. Just going to remember that type of stuff. And you're going to iteratively give it feedback. And at some point, it will then be able to more gradually start doing automatic data entry for you. But it's the same as you're hiring a new employee. Like they might also make that mistake. They might also not know that Bob typically wants an A3. So you need to then explain it. And if you explain it enough, the nice thing with AI is it will never forget. And it will never make that mistake again. Okay. The lab management system, I think, of course, in the LMS itself, people will also start optimizing workflows, looking where the bottlenecks are, maybe try to optimize pricing, those types of things. Interestingly, I was talking to Reed Donnelly from Derby, like 1 hour ago. So I added these two. He was saying to me, I'm playing with like Replit and Lovable. Like these are websites that let you build your own apps. I can also see a world where you're just going to start building your own LMS, really tailored to what you need. Because now, I don't know, try these apps out in a free weekend. Like you can just fully build a website right now in 30 minutes. Like I'm getting married in June. I just made this website for our wedding in like 30 minutes. Just type what I wanted to do. That would have taken months and tens of thousands of euros to get that type of stuff done in the past. Now it's just one click of a button. Okay, so after the LMS, of course, it's we put the CAD part, which is going to be automated. That's again where we position ourselves. But we're not the only ones that are doing AI here. Of course, TreeShape, ExoCAD, CADflow, H3D, all building these types of workflows for automatic design. All of their focus areas, I think TreeShape, of course, now very focused on crowns. You have Dentscape, also crowns. ExoCAD also has crowns now. CADflow is more orthodontics. Like they have a lot of different types of models for orthodontic labs. H3D has custom trays and splints. We also have custom tray splints, and then also the crowns and all types of models that you can make. So that's going to be, and I think if you might ask me, what are you going to do in terms of CAD? Everything. Like I think everything that you do in ExoCAD today, give it 24 months, one of us is going to be doing everything. So I think this is going really, really fast right now in terms of the types of stuff we're doing. Finally, of course, we need to build then that API integration to the CAM side so that everything flows nicely. And I think you saw where I was putting like, oh, this app, that app, it's all spread out right now. I think that's frustrating. I think it's up to us as companies to link everything nicely together so it becomes one solution, one workflow, and not, oh, I'm going to use this app here and upload it here and then download it back here. Like that's not the goal of what we're trying to achieve here. So a lot of API connections to make sure everything flows from start to finish, where you can have an order come into the lab, automatically download it, read what was in the order, make sure there is a quality control after 2 minutes, let them know if it was fine or not, then do the data entry in the LMS. LMS manages that all, automatically design that crown or whatever, or with the implant model, and then put it on the printer. Like those types of workflows honestly will be possible in 24 months. And I think that's very exciting. I think it's definitely gonna make US labs, very competitive also. Right, that was what I wanted to tell you today.